Mr. Harrison Marshall, one of your best videos yet. Thanks. Thank you very much, Mr. Harrison. Though I cannot reply to all your messages, I actually read all your messages. Tom Branson, it seems that based on the rules, the GNU and the Clang compilers are doing that correctly. And I checked on casting result in MSVC with the latest compiler Visual Studio 2019. It appears that the result is the same as GNU and Clang. It might have been a bug that is fixed. Sure. As you see, I always use up-to-date pre-release. I'm using beta version of latest compiler of Visual Studio. So when I found a bug, then in the next or future release, Microsoft engineers fix the bug in future release. So don't worry. Thank you very much, Mr. Tom Branson. Venkata Krishnan, very glad to hear your response. I remember your request. You asked me to implement TOEFL, but trust me, implementing TOEFL is simple and straightforward, so don't worry about the things. Implementing vector correctly is very advanced, but implementing TOEFL is simply type functions. Mr. Heng Chang, my old friend, so nice to see you back in English channel. So sad that I don't understand Korean. Thank very much, Mr. Heng Chang. You are my old Chinese friend. Happy New Year, Mr. Heng Chang, on lunar calendar. Triangles, thank you for such awesome educational contents. Triangles, thank you very much. I like triangles too. Triangles are the basis for any mathematics. Please understand that though I don't reply to all your messages, I actually read all your messages. Hi everyone, my name is Thomas Kim. Today is January 29th, 2021. This is my 66th episode about the programming language C++ training standard. In this episode, I will discuss implicit recursion through C++ operator functions. Never ever forget that whenever we overload C++ operator functions, you are using recursion by default or implicitly. Never forget that when you overload C++ operator functions, you are using recursion. Scroll down from our previous episode 65. Please double click this link. If you haven't watched this video, episode 65, please don't miss this. Click show more in the download source code section. Episode 65, double click this link to download our previous source code. Show in folder, extract, rename, 66, implicit, recursion. Copy the folder, paste it in your working folder. Please understand that whenever we overload C++ operators, we are using recursion. Start Visual Studio Code. Open CPB20, our working folder. From the folder 66, double-click array.cpp, Ctrl-V, Ctrl-N. If you scroll up, you can find print tuple. We implemented this function in our previous episode. So if you missed my previous episode, please watch them. Otherwise, you cannot follow my current and future sessions. In our previous episode, we used workhorse pattern. We created a lambda here. Then we passed workhorse the lambda by passing make typed sequence. Then we implemented print tuple. This implementation is not recursion. Implementing print tuple to a recursive function call is piece of cake. But what is more important is this part of code. Please understand that index is used here. Index is compile time constant that forms a type index t. This drive workhorse pass an argument index t to this workhorse lambda. This syntax is C++20 standard. We can also implement this pattern using C++17. The reason I implemented like this is to explain this new lambda syntax in C++20 standard. Now it served its purpose. I will implement the same algorithm using C++17. Now Control Home, Control F, indexer T, then you can find this file. Now here using type T static context pair T index, I will change it to value, copy this, paste it here. Context pair. Please understand that index T is simply type alias for index type. Control F, drive, workhorse. In this implementation, drive workhorse passes an instance of index T. So drive workhorse calls our workhorse by passing an instance of index T. Index T is simply indexer type. It has type and index as its member. Now find print tuple here, expand. I will copy this and paste. I will disable it like this. Now here in C++17 we cannot provide a parameter like this. Here auto indexer. Okay, this element indexer has member index, also index. Please understand that we should not use L-value reference or forwarding reference. L-value reference or forwarding reference, they are pointers internally. Pointers means it needs memory. Once again, L-value reference or forwarding reference, they are reference. Reference requires memory, internal memory at runtime. We need compile time constant index. So we cannot use reference or forwarding reference here. I hope you understand this point. This is C++ compatible implementation. Now scroll down. Test print tuple, we created this function in our previous episode. Control End, I will disable it. Now we are testing print tuple. Start command prompt. CD 066 implicit recursion clang std C++20 array.cpp ltvb oc.exe. We still have to use C++20 because I used the concept in array.cpp, so we still have to use C++20. Now hit enter. CLSC. So using C++17 compatible syntax, we can extract index. This index is compile time expression. Now I will delete this code. This is an element of tuple. So auto, this is L value reference, V, copy this. Please understand that V is L value reference. V is index's element of tuple. Now V here. Also, we want to extract the type of V like this using V type std tuple element t. We use indexer index. Then the type of tuple deckel type tuple, but this is not good enough. We have to remove std, remove cv ref t. We have to remove reference from the type of tuple. I understand this syntax is very ugly. There is easier, simpler way. I will discuss that shortly. Now, if context pair, we are testing if V type is tuple. How can it test this type is tuple? We created tuple C. We provide V type. Then else, this belongs to else part. I will indent. If V is tuple, then print tuple V. This is recursion. Now scroll up. I will delete this part for easier read. Please note that we are in Workhorse. In this Workhorse, if the index element of tuple is tuple, then we call this function recursively. We are calling print tuple recursively. Please understand that tuple C is defined here. We implemented this concept in our previous video. Print tuple again. Now we implemented this print tuple recursively. We are still in Workhorse like this. With this, here void test print tuple recursion. Copy this function, paste it here. Now disable it. Now here std tuple a 122.0 over 7.0. My dear audience, std tuple b. We are all C++ programmers. I welcome any people who love C++, SCD, TOEFL, audience, Syme, Musliu, Harrison, Marshall, Tom, Branson, Venkata, Krishnan, Heng Chang, and my other friends and audience, SCD, TOEFL, TOEFL, TOEFL A, TOEFL B, audience, we are all friends. Print, TOEFL, TOEFL. Now, in the command prompt again, we build using Clang compiler once again. CLS C. Let's see. This is our first tuple A. Tuple A is defined here. This is our second tuple, tuple B. Tuple B. This part up to this point, audience. Audience. There is a glitch here. We are all friends. We are all friends. There should be a comma. Now scroll up. In the print tuple again, copy this, cut, and paste it here. Please note that we are in Workhorse, like this. I said this syntax is very ugly. Disable this. Paste. I scroll up. We are in print tuple. We are in Workhorse lambda, like this. We can access this parameter. Copy. Then we can paste it here. Scroll down. We also need this. Copy. Paste it here. Now in the command prompt again, CLS, we build again. CLSC. Now we implemented correctly. There is a comma and it resolved properly. As I said in the beginning of this episode, if we use C++ operator overloading, the recursion is implemented automatically, implicitly. So we don't need such recursion if we implement operator overloading for tuple. Such recursion is unnecessary. So I will explain how to overload output stream operator for tuple. Template, type name, element types, SCD, OStream. This is return type, operator, output stream, SCD, OStream. It should be L-value reference, OS, constant, SCD, tuple, element, types, ellipsis. It should be L-value reference, tuple. Context pair, auto, size, size of element types. If context pair size equals 0, that means our tuple is empty. OS empty parentheses. Else OS open curly brace auto workhorse. We capture tuple auto indexer. We create workhorse lambda. Please note that we also have to capture OS. So capture OS as L-value reference. OS SCD get indexer index tuple. We can access element types. I copy this, paste it here. If context pair indexer index plus 1 is not equal to size OS. Please note that we are in Workhorse lambda. In Workhorse lambda, we have to return any value. Now, here we have to drive this Workhorse. Drive Workhorse. We are passing our Workhorse here. Make typed sequence. We pass size. Please note that this is type. We have to pass an instance like this. Now, please understand that we are here. We have to return OS like this. Let me now expand. Let me explain why it is a recursion. We are defining output stream operator here. This output stream operator is this operator. OS is this OS. STD tuple is this tuple. It is recursive. If this element is tuple, this operator is called recursively. In C++, binary operator overloading is recursive. Now, Ctrl F operator plus this operator plus is recursive. It looks different. Obviously, this operator is not this operator. If not, we can make copy, paste, then this operator is recursive. Also, minus, copy this, paste it here. Now this implementation is recursive. Tuple A, tuple B, minus. Tuple 1, tuple 2, minus. Also, copy this, paste it here, multiplication. This is also recursive. Also here, copy this, paste, recursive. This forms tuple A, this forms tuple B, division, division. Now, Ctrl N. We test this operator like this. Here, copy, paste, test print tuple using operator overloading. Now here, disable this std cout tuple std and there. Now we are using stream operator. Copy this, paste it here, disable this. We built using clang compiler again. CLSC. I guess something wrong. Scroll up. We open the curly brace. We have to close. We rebuild CLSC. Now works perfectly. Please understand that this part, if the element of tuple itself is tuple, this operator is called recursively.